Hi students, in my lecture number 3 video, then because of some technical issue, some preparations have raised. That's why in today's class, that is lecture number 3 by A, whatever the topics have raised, those topics once again I am explaining. Then we'll see the preparations. The first preparation is reduction of nitro compounds. Already reduction of nitro compounds have explained. Second preparation is ammonolysis of alkyl halides. It is also called as a Hoffman's ammonolysis process. Now we'll start from this preparation method. Right. Ammonolysis of alkyl halides. We'll try to understand what happens actually here. First here we will take one closed container. One sealed tube we have to take. In that sealed tube, we have to take excess of alkyl halide. To that excess of alkyl halide, ammonia we have to add. Excess of alkyl halide and ammonia mixture we have to keep in one closed container, and that container we have to heat at 100 degrees centigrade, nothing but 373 kelvins temperature. 373 kelvins temperature if you heat. Here what happens means successive ammonolysis takes place. What is meant by successive ammonolysis? Let's discuss now. Once again, then in ammonolysis of alkyl halides process, we will take one closed container. In that closed container, excess of alkyl halide and ammonia mixture we have to take, and that container we have to heat at 100 degrees centigrade, nothing but 373 kelvins temperature. Then a successive ammonolysis takes place. Because of successive ammonolysis, then continuously first primary amine, then a secondary amine, then tertiary amine, and finally quaternary ammonium salts are obtained. Those reactions we'll discuss now. See here carefully. Right. First of all, what happened in the first stage? Ammonia, nitrogen is having a lone pair which is acting as a nucleophile, is reacting with the alkyl halide. Then alkyl halide, definitely polar molecule, here partial plus charge, partial minus charge will be developed, and on partial positive charge and nucleophile. Then ammonia is acting as nucleophile, is going and attacking on alkyl group. Therefore, between nitrogen as well as alkyl group, a bond is forming. That bond is showing like this: R, NH3 plus and X minus. Means after donation of electron pair, nitrogen is getting plus charge. Nitrogen is getting plus charge. Therefore, R, NH3 plus X minus, one intermediate compound we are getting, and this compound, nothing but it is a salt, of course. This salt is heated with or reacted with sodium hydroxide. We'll get RNH2. Otherwise, we'll do one thing. Here one hydrogen will just separate, convenient purpose. And here OH and H eliminated as water. And NaX, of course. NaX eliminated as sodium halide. And our main component is RNH2. RNH2 is obtained. That is nothing but primary amine. Primary amine is obtained in the first stage. And after formation of primary amine, reaction has not stopped. Successive ammonolysis takes place. Reaction is not stopping. That primary amine is reacting with one more alkyl halide, because we have taken excess of alkyl halide molecule. Therefore, that primary amine is reacting with another alkyl halide molecule. Same story again. Now here primary amine is acting as nucleophile. In previous case ammonia was nucleophile. Here primary amine is acting as nucleophile. It is donating electron pair. Again between nitrogen and alkyl group, a new bond is forming. We'll write like this: R, N, R. See here R, NH2. R, NH2 as well as R. Therefore we'll write like this. And one H will separate, and one more H is there. Another H will write like this. And it is a plus charge as well as this part is plus charge. Next, otherwise we'll write by merging R will write directly R2, doesn't matter. R2 NH, one hydrogen I am separating, it is a plus charge. X minus will get one salt, and whatever the salt we are getting, this salt is reacted with the sodium hydroxide, and will get R2NH, quite similar, no doubt. H2O plus NaX, that is a secondary amine, is obtained in the second stage. In the first stage we are getting primary amine, and at primary amine stage reaction has not stopped. That primary amine immediately reacting with one more alkyl halide will get secondary amine, and at secondary amine stage also reaction has not stopped. Again secondary amine is reacting with another alkyl halide molecule, R2NH, one more alkyl halide molecule, and it is also again polarity existing. Lone pair is donating because acting as nucleophile, secondary amine, and will get now R2 and R will get now R3, N hydrogen you can separate, X it is a plus, it is a minus. Again reacted with the sodium hydroxide, will get R3, N plus byproducts are quite similar, that is a H2O and NaX, that is a tertiary amine is obtained. Tertiary amine is obtained. Once again, first ammonia reacting with alkyl halide will get a primary amine, and that primary amine reacted with another alkyl halide, secondary amine. That secondary amine is reacting with another alkyl halide, we are getting a tertiary amine. Now at tertiary amine stage also reaction has not stopped. Again the tertiary amine is reacting with one more alkyl halide because we have taken excess of alkyl halide. That alkyl halide reaction I will write here. Last reaction I am writing here, that is R3, N is reacting with one more alkyl halide. Again now tertiary amine is acting as a nucleophile, and will get R3 and R4, N plus X minus. Then it is of course a salt, and this salt is not reacting with NaOH because no hydrogen at all. At quaternary its name is quaternary ammonium salt. Its name is quaternary ammonium salt. At quaternary ammonium salt reaction will be stopped. This is called as a successive ammonolysis process. In the first stage we are getting primary amine, in the second stage we are getting a secondary amine, next tertiary amine, and finally we are getting salt. It is not amine, remember, it is just a salt only. Quaternary ammonium salt is obtained at last. All these are general reactions. Why? Because we have used R. Which alkyl group we have taken, that we don't know. That's why these are called as general reactions. Now we will take examples. Examples purpose what I am doing, instead of R I will write ethyl, suppose ethyl. Instead of X I will take a bromine, any halogen, doesn't matter. Same reaction again here, polarity existed. Then wherever R is there we have to write ethyl group. Ethyl group we will write. Wherever X minus is there we will write Br. And finally we will get ethylamine and NaBr. That's it. Ethylamine, nothing but ethanamine, which is the primary amine. Means when ammonia as well as ethyl bromide both are reacted to each other, in the first stage we are getting ethylamine. Exactly, remaining reactions also we can write. That is same ethylamine reacted with one more ethyl bromide. Ethylamine reacted with ethyl bromide will get a salt. That salt reacted with the sodium hydroxide will get secondary amine. Secondary amine structure is C2H5 taken twice NH. That is a diethylamine is obtained. Now secondary amine, that diethylamine is reacted with one more ethyl bromide molecule will get a triethylamine. Triethylamine is obtained, and this of course a tertiary amine, triethylamine. This tertiary amine if reacted with one more alkyl halide, and finally will get finally structure is C2H5 taken 4 N plus Br minus, quaternary ammonium salt, and its name is tetraethyl ammonium bromide is obtained. That's all. Tetraethyl ammonium bromide, which is a final compound in this reaction. Reactions you can write quite similar. Right. Now will discuss some more points regarding this process. That is, yeah, the main disadvantage of this process is here we'll get all mixture of compounds. I'll repeat, we'll get a mixture of primary amines, secondary amines, tertiary amines, and quaternary salt mixture is obtained in this process. And from that mixture, separation becomes a difficulty. Okay, here main drawback of this method is we will get a mixture of components, separation becomes a bit difficulty. That is one problem. Suppose we can get primary amine, no doubt. Reaction we can stop at primary amine stage. For that purpose, what we have to do? We have to take instead of alkyl halide, instead of excess of alkyl halide, we have to take excess of ammonia. This is important point. Instead of excess of alkyl halide, if you take excess of ammonia, reaction will be stopped at primary amine. Stopped means primary amine is obtained as major product. That's it. Instead of excess of alkyl halide, if you take excess of ammonia, then the major product is primary amine. Of course, the remaining also obtained, but very minute level. Major amount is primary amine. That's it. Next, one more important point. That is, from this method, it is not possible to prepare aromatic amines. Aromatic amines is nothing but aniline. For example, aniline. It is not possible to prepare aniline. Why it is not possible to prepare aniline? Very simple. To get aniline, here we have to take halobenzene. Halo, that is a bromobenzene has to take. Suppose if you take bromobenzene, what happened then? Already in first lesson we have learned haloarenes, because of resonance will get here a double bond character. Here breaking is difficulty. And at the same time, haloarenes are less reactive towards nucleophilic substitution. Haloarenes are less reactive towards nucleophilic substitution reactions. That's why from this method, that is a amino benzene, that is nothing but anilines we cannot prepare. That is aryl amines we cannot prepare. Why? Because haloarenes are less reactive towards nucleophilic substitution reaction. That's it. This is second preparation to get amines. Okay, that is called as Hoffman's ammonolysis process. Right. Then we'll go to third preparation. That is a reduction of nitriles. Now, what is nitrile is question mark. Nitrile is nothing but cyanide. See, RCN, its common name is alkyl cyanide. Its IUPAC name is alkane nitrile, and its clear structure is like this. R C triple bond N is its clear structure. Now what we have to do? We have to do reduction across the triple bond. Our target is this cyanide, this nitrile, we have to convert it to RCH2NH2. RC triple bond N, we have to convert it to RCH2NH2. Means addition of hydrogen should occur, nothing but reduction should take place. Right, how reduction is taking place? Let's discuss now. R C triple bond N is undergoing a reduction. Reduction purpose we have to use reducing agents. Then what reducing agents we are using? Means we can use a catalytic reduction process also. Number one, catalytic reduction. Catalytic reduction is nothing but addition of hydrogen in the presence of nickel or platinum or palladium metals. It's called as catalytic reduction. We can use that method, or sodium metal or sodium amalgam also we can take. Sodium in the presence of ethyl alcohol. Either this reagent or this reagent when we are using across the triple bond reduction is taking place, and we will get RCH2NH2, will get corresponding primary amine is obtained. Okay, it is alkane nitrile, we will get corresponding primary amine. We will take an example. Instead of R, I will take a CH3, C triple bond N. What is its common name? Common name is methyl cyanide. Methyl cyanide. What is IUPAC name? Two carbons are connected to each other. Ethane nitrile. Ethane nitrile is its IUPAC name. Ethane. Last letter E we should not remove. Why? Because here nitrile secondary suffix starting letter is not AEIOU. We will keep primary suffix last letter E as it is. Right. Same reduction is taking place. Either this reducing agent or this reagent, doesn't matter. We will get CH3, CH2, single bond NH2. Its name is ethylamine or ethanamine is obtained. Ethanamine, which is absolutely primary amine. Now here one important point we have to learn, that is when nitriles are undergoing a reduction with sodium in the presence of ethyl alcohol. Sodium or sodium amalgam, of course, in the presence of ethyl alcohol, if a reduction takes place, that reduction process is called with one particular name. It is called as Mendes reduction. That's it. Mendes reduction. Particularly sodium in the presence of ethyl alcohol, that reduction process called as Mendes reduction. That's all. Now here one more important point we have to learn, that is generally this method is used for ascent of series. Ascent of series. What is the meaning of ascent of series? Ascent nothing but increasing of alkyl group. I mean increasing of carbon chain is nothing but ascent of series. Then question arises, how carbon chain increases? Here also as a reactant 2 carbon, as a product also 2 carbons only. Where carbon chain has increased, why it is called as ascent of series? Very simple. Actually the thing is, this is nitrile, nothing but a cyanide basically obtained from alkyl halide like this. CH3 Br reacted with potassium cyanide. Alkyl halide reacted with the potassium cyanide, then we'll get a cyanide, corresponding alkyl cyanide, that is ethane nitrile or methyl cyanide is obtained. Means actually whatever the cyanide compound is there, because of its less stability, it is obtained from its parent compound alkyl halide. Means you have to focus on alkyl halide. In alkyl halide, how many carbons are there? 1 carbon. And after completion of the reaction, after formation of our amine, how many carbons are there? 2 carbons. Means the number of carbons are increased. Because of that reason, we will call it as ascent of series. Once again, don't focus on cyanide compound, because cyanide is obtained from alkyl halide. Then how alkyl halide is converted into cyanide? Means when alkyl halide is reacted with the potassium cyanide, then what happened? Then KBr eliminated, CH3CN is obtained. Then as a reactant we are having 1 carbon. As a product we are having 2 carbons. That's why we will call it as ascent of series. Alright. Next preparation method we will discuss, that is reduction of this third means of course fourth one, reduction of amides. Reduction of amides. We'll see how amides undergoing reduction. Amide is nothing but RCONH2 should convert to, this is CO should convert to CH2, that's it. RCH2NH2, that's all. I'll repeat, when amide undergoing again a reduction means you are removing of oxygen, removing of 1 oxygen, adding of 2 hydrogens, nothing but reduction process only. RCONH2 should convert to RCH2NH2, that is a primary amine. Amide should convert to amine. For this purpose, we need a reducing agent. In this case, we are using a strong reducing agent, that is a lithium aluminum hydride followed by hydrolysis process. That's it. When amide is reducing with lithium aluminum hydride followed by hydrolysis will get a corresponding amine. We'll write example. Instead of R, I'll take a CH3 CONH2. Its name is acetamide, which is of course common name, and IUPAC name is 2 carbons are there, eth plus an plus amide, ethanamide reacting with the same reagents and CO converted to CH2. Therefore, we'll get a CH3 CH2NH2, that is a primary amine. Its name is ethanamine. I'll repeat, ethanamide converted to ethanamine. It is mide, it is mine. That's it. I mean, amide, amine. Right. This is fourth preparation method to get amines. Then we'll enter into fifth preparation method, that is, which is again important reaction. That reaction, it is a name reaction. We'll see now. We'll do one thing. We need some space. That's why that PU2 as well as lecture 3 by A I'll write here, because we need a space for this reaction, and it is a name reaction. Its name is Gabriel phthalimide synthesis. Gabriel phthalimide synthesis. It is a name reaction. Right. Then in this method, how we are preparing our corresponding amines, let's discuss now. We'll do one thing. Gabriel, scientist name of course. Here we need a phthalimide. Phthalimide structure is required. Actually, phthalimide preparation will learn in carboxylic acid topic. Right. Now, first I'll explain how phthalimide is obtained. First we'll discuss about phthalimide preparation. After phthalimide preparation, then we'll start actual process. Very simple. When a benzene is having a COOH groups adjacent to each other, its name is called phthalic acid. Its name, phthalic acid. When phthalic acid is reacted with ammonia, it is acid, it is a base, you will get a salt. The salt formation is like this. Benzene with COONH4. One ammonia reacted here, one ammonia reacted here. Again here COONH4. Phthalic acid, when reacts with ammonia, you will get ammonium phthalate. Ammonium phthalate. When ammonium phthalate is heated, from here one water molecule, from here one water molecule, 2 water molecules are eliminated, then we will get a structure like this. Benzene with CONH2 and CONH2 is obtained. Its name is PHTHALA. Phthalamide is obtained. Phthalamide. Phthalic acid is giving a phthalamide, and its name is ammonium phthalate. Ammonium phthalate. And it is a phthalamide. But we need phthalimide. Phthalimide is required. That's this phthalimide once again heated, excess. Once again heated, then from here NH2, from here H, from here NH2, from here H eliminated as water, sorry, ammonia eliminated. Then the obtained structure is benzene ring with CO and CO. CO will write as it is. From here NH2, from here H, after elimination only NH is left. NH has connected both the CO groups like that. That compound is called as phthalimide. pH, phthalimide. PHTHALIMIDE. It is a phthalimide. Be careful regarding the names as well as the structures. Now, in a Gabriel phthalimide synthesis process, our starting compound is this one. Our main starting compound is that one. That compound will take and will get our required amines. That process we'll discuss now. Right. Whatever the reaction just now we have learned, that reactions will learn in actually carboxylic acids topic. Okay. Now Gabriel phthalimide synthesis process we'll discuss now. Benzene ring, CONH. Phthalimide, pH, phthalimide. When phthalimide is reacting with alcoholic potassium hydroxide. Then here between nitrogen and hydrogen, because of electronegativity difference, then nitrogen is taking a bond pair of electrons towards itself, and hydrogen is eliminating without electron reacted with OH minus. Water has eliminated. Water is eliminating. Therefore, the obtained structure is like this: benzene ring, CO, and of course N. After shifting of electrons, nitrogen is getting a minor charge, and here a K plus OH minus. K plus is coming and here forming, like it's like salt formation is taking place, and its name is a potassium phthalimide. Potassium PHALIMIDE, potassium phthalimide, which is a salt. This potassium phthalimide reacts with the alkyl halide. Important step. When potassium phthalimide is reacted with alkyl halide, what happens? This K plus X minus eliminated as KX, and alkyl group is coming and substituting. Therefore, you will get a benzene ring, CO NR. Its name is N-alkyl, N for nitrogen, N-alkyl phthalimide is obtained. N-alkyl phthalimide, PHTHALIMIDE, that's it, N-alkyl phthalimide, right? But still amines have not obtained. N-alkyl, nitrogen alkyl phthalimide has formed till now. And in the last step, same structure once again I will copy here. N-alkyl phthalimide I will write here. CONR. When this N-alkyl phthalimide is reacted with alkali sodium hydroxide, balancing purpose I am taking 2 moles of sodium hydroxide. Very simple. What happens means this bond as well as this bond, both the bonds are breaking. Now the obtained structure, let's see what happens. Benzene ring and CO, here also CO, right. Now we'll see what happens. Now this bond is breaking, this bond is breaking. This CO is connected with ONA, COONA, therefore COONA, and this CO also connected with the ONA, COONA plus here RN is left. This RN reacted with the 2 hydrogens. 2 hydrogens are there. That's why finally we'll get RNH2, which is primary amine is obtaining, and its name is sodium phthalate. Sodium phthalate. Along with that, our required primary amine is obtaining. Once again, we'll see. It is a phthalimide. How phthalimide is obtained? Already I have explained. Of course, those steps are not necessary here. We have to start from this compound only. This phthalimide is reacted with the potash, nothing but potassium hydroxide. Water molecule eliminated, we are getting a salt. Its name is potassium phthalimide. This potassium phthalimide reacted with alkyl halide. KX eliminated, you will get N-alkyl phthalimide. This N-alkyl phthalimide is reacted with again sodium hydroxide. You will get a sodium phthalate. Your name is sodium phthalate. And our required primary amine is obtained. Now, we will discuss some important points regarding this method. What points are there regarding this method? One is, from this Gabriel phthalimide synthesis, we will prepare exclusively aliphatic primary amines only can be prepared. I'll repeat. With this method, we can prepare exclusively aliphatic primary amines only can be prepared. Aromatic primary amines as well as the secondary amines as well as the tertiary amines are not possible to prepare. Then question arises here. Why only aliphatic primary amines we are preparing? Why not? Why not aromatic primary amines? Nothing but why not aniline we are preparing here? Why aniline is not preparing? Why only aliphatic amines we are preparing? Aliphatic primary amines we are preparing. We'll just see the reason. See here. We are getting a alkyl amine. From where this alkyl group we are getting? We are getting alkyl group from here. Let's say what I am doing now, instead of alkyl, suppose, just imagine, instead of alkyl, if I substitute aryl, halobenzene if I take, just imagine, halobenzene if you take, then what happens? Reason already known to you. Because of resonance between a halogen as well as this carbon will get double bond character. Because of that reason, this halobenzene is not participating in the nucleophilic substitution. This it is not coming and attacking on the nucleophile. Here nitrogen is acting as a nucleophile. I'll repeat. If you take halobenzene, you will get aryl amine. I mean aniline is obtained. If you take halobenzene, you will get aniline. There is no doubt in that. But if you take here halobenzene's nucleophilic substitution reactivity is very less. That's why these halobenzenes are not participating in the reactions. That's it. That's why aromatic primary amines are not possible to prepare in this method. We will prepare exclusively aliphatic amines. That's it. And in lecture number 3, up to this concept, because of some technical issue, that part has raised. Now all the compounds, all the reactions have covered, and the remaining things will be as it is only. Thank you for watching. Bye.